Let's go ahead and get started here. Some questions on 7, 8, 9 in that area there. So let's take a look at that real quick. We want our main focus today to be for the gateway test. So there's some of you had multiple pages of practice from page 195, which is really good. That's going to be helpful to you in trying to pass this gateway test on Tuesday. Some of you, I think, must think I'm just pulling your leg about maybe how much practice it's going to take to pass this thing on Tuesday. I don't know. But I'm not. So, but there's quite a few days now between now and Tuesday, so you do have some time. So on 7, it says sine arc cosine of x, and then you're supposed to just find the value of that, or the directions exactly. It said rewrite the expression as an algebraic expression. In other words, it's going to have x's in it. So this is what we did yesterday as we were on our path to the derivative rule, right? We actually did the reverse of this. We did cosine of arc sine of x, I believe. But anyway, it would be this, and it turns out to be a very similar answer. It may be exactly the same answer. And a few people that came and asked me about this morning were confusing it with the derivative question. We did this on our way to the derivative question, but this would be more a last year kind of trig kind of thing. I'm not sure you ever did it with x's. You probably did it with actual values in there. So the idea is arc cosine of x means the angle whose. Now remember, in the arc cosine function, it's important to remember that what goes in here is values. These will be numbers between -1 and 1. And then this output here is angles, like pi 6. It's the reverse of the cosine function, where you put angles in and get values out. It's the inverse. So when we do arc cosine of x, it's like saying what angle would have an input value, or what angle would have an output for cosine of x? Well, that would be this triangle. That would be this angle right here, because cosine is the adjacent over the hypotenuse leg. And then if we do Pythagorean theorem to this, it's the same thing we did yesterday. It'd be this squared minus this squared, and then the square root of that by Pythagorean theorem. So this would be that to finish that triangle. And then we want the sine of that angle. So this is like our theta then here. That's the angle. And so we want sine of that angle, which would be opposite over hypotenuse. So the answer there would be just 1 minus x squared, like so. Okay? Now if you get, did we do number 8? Or did we do odds there? So it was number 9. So cosine of arc tan of x. So cosine of arc tan of x. So again, we would want to draw for that inside. We want to draw the angle whose tangent would be x. Well, tangent is the opposite over the adjacent, right? Opposite over the adjacent. And so that would be this, x over 1. And then if we do Pythagorean theorem, it would be 1 squared plus x squared, and then the square root of that. So it would be 1 squared plus x squared, and then the square root of that. And so the cosine of this triangle would be 1 adjacent over hypotenuse. So it would be 1 over the square root of 1 plus x squared. So that's what number 9 is. So again, not something that we worry about for the gateway test at all, but it's how we arrived at the derivative of these inverse trig functions using this stuff we learned last year about just trig values and those things. Okay? And then there seem to be some issues at the end there with 37 and some of those. So let's talk about that. This has to do with the, like 37, arc sine of phi. Okay? And that does not, what they say is that does not equal phi. Okay? Well, on your calculators, go ahead and do that. Just type in arc sine of phi. let's do this. Let's do Control Enter. That would be better today. Let's do arcsine, which is this, of sine of 5, and we'll go Control Enter. Okay, and we get that, right? Now, let's think about that here a minute. So, sine, let's just do the inside, sine of 5. Okay, so let's think about that a minute. What is that 5? Tell me what that 5 represents. Isn't that 5 radians? Now think about it. This is the sine function we're talking about. What goes into the sine function? Angles, right? Pi 6, pi third. We do sine of pi 6, pi third. That 5 is an angle in radians. Where is 5 radians? How many radians are here? 3.14. Pi. Ooh, nice circle. How many is there? 3 pi over 2, which is 4.71. Everybody should know that number, right? Maybe. But it's, right, this is 1.57, this is 3.14, this is 4.71, and this is 6.28, right? Okay? So if you didn't know, now you do, right? So 5 radians is right here, right? So sine of 5 radians is this angle right here. Now we want the arcsine of that. Now here's what we did yesterday. We did the arcsine of the sine. Let's do one where we know the answer. Pi 6. Well, what's sine of pi 6? 1/2. And the arcsine of 1/2 is pi 6. So you got, so the arcsine of the sine of pi 6 was pi 6. They cancel each other out. But then we did this. We made that 5 pi 6. What's the sine of 5 pi 6? 5 pi 6 would be over here. What's the sine of that? 1/2. So the sine of 5 pi 6 is 1/2. What did we just say the arcsine of 1/2 is? Pi 6, right? Because you can only get one answer out of a function. The arcsine is a function. Arcsine of 1/2 is pi 6, not 5 pi 6. And so why did we not get 5 pi 6? Because you had to restrict the domain. Arcsine only is going to give values in what quadrants? 1 and 4. 1 when sine is positive, 4 when sine is negative, right? Or when this value is negative, right? So, 5, is that in quadrant 1 or 4? Now, when I say quadrant 1 or 4, what I really mean is between negative pi halves and pi halves. That's what we mean, right? So I think I talked about that yesterday. I said if this was negative 1/2, what would be the arcsine of negative 1/2? Negative pi 6. And I know I distinctly remember saying this. Negative pi 6, not 11 pi 6, right? When we go 0 to 2 pi, which is what we're used to doing, we would go all the way around 11 pi 6. But that's not the answer you get on the calculator. You can try it, right? Go ahead and do arcsine of negative 1/2 right now. Do arcsine of negative 1/2. And I'll bet you $100 and 3 donuts that it's negative pi 6. Right? Okay, you guys owe me $100 and 3 donuts. All right. Not 11 pi 6, because you're, okay, so you're getting quadrant 1, quadrant 2, or quadrant 1, quadrant 4. So back to this. Arcsine of the sine of 5. So this is like 11 pi 6, in other words, right? We're not going to get out 5. We're going to get what? We're going to get that. Well, what is that? Well, 6.28 take away 5. 1.28. Negative. That's why we get negative 1.28. That's equivalent. That's the equivalent angle of 5. just like 11 pi 6 is the same angle as negative pi 6. Same angle in the sense it's the same terminal side. It's not the same angle, right? One goes this way, one goes that way, but, right, same terminal side. So that's why arc sine of 5 is not 5. It's because of that domain restriction and the value it gives you out. I think it's easier to see when you're doing that, when you think of it with numbers we're used to, right, with the pi 6 and things like that. Okay? All right, 38. For which values of x does that hold? Well, that's what we were just talking about. So x is those angles, so what values, I erased it, but that'd be the negative pi halves to pi halves. Negative 1.57 to 1.57. For those values, you're going to always get back what you started with. Okay? Oops. 39. Let f of x equal arc sine of x. Show that f prime equals this. Okay, so this is a good one. So this actually involves derivatives. So f of x equals arc sine of x. Now we said that in an ideal situation, this would just equal x. So in an ideal situation, f prime would actually equal what? Derivative of x is 1. So in an ideal situation, it would just equal 1. But let's go ahead and follow our derivative rule here. So the derivative rule of arc sine is what? 1 over square root 1 minus the inside squared, so that'd be sine squared, times the derivative of the inside, cosine of x, right? Now, look at that bottom. And so this cosine I'm going to go ahead and put on top. Now look at the bottom. What's 1 minus sine squared? That's cosine squared. What's the square root of cosine squared? Be careful, we talked about this yesterday. What's the square root of x squared? Not plus or minus, but absolute value of x, right? Because if you put a negative 3 into there and square it, it becomes positive, and then you square root it, you get a positive, not a negative. You always get a positive out of a square root. So this is going to be a positive, but cosine could be negative here, right? So this becomes cosine x over absolute value of cosine x. And so that's what they wanted you to show on number 39. Okay? Now, think about what that would be. What's cosine over absolute value of cosine? Well, if cosine's positive, then what does that equal? 1. If cosine's negative, negative 1. Look at that graph. I call it the Charlie Brown graph. Doesn't it remind you of that? That's exactly his shirt. Isn't that what his shirt does? I don't know. Whenever I see that, I think of Charlie Brown. All right. Anyway, that's coming up too. Charlie Brown Christmas. Or has it been on? I think that's coming up. All right. It's a great show. But anyway, what are the slopes? What are the slopes on that graph? 1 or negative 1. Right? There's a derivative. They're either 1 or negative 1. Now, where are they 1? They're 1 from negative pi halves to pi halves. Right? Well, from negative pi halves to pi halves, doesn't arc sine of x equal x? That's what we just got in saying. In the first and fourth quadrants, it is just x, so the slope is 1. But then you go from pi halves to 3 pi halves, that would be in the second and third quadrants, right? What is cosine in the second and third quadrant? Negative. So this would be negative, this would be positive, you get negative 1. Then you go, keep going, then you go from 5 pi halves, or 3 pi halves to 5 pi halves, I guess. Now you're back in the first and fourth quadrants. And so now you get 1, right? And so that's why that graph looks like it does. Okay? Both value-wise and slope-wise. Okay? So again, it's a good problem. And there's a little bit of this practice. This would be a fair problem to put on the gateway test. Give you this, you do the derivative, right? A little bit of simplifying it. Okay? That whole thing with the absolute value, I don't know that I'll really have you do anything like that. But okay? One other one we should talk about is number 21. Yes. If you're honest with yourself, I'm guessing you had trouble with that one. Okay? If you didn't, that's great. That's really, really good, as a matter of fact. But it said this, and we had no rule about arcsecant. At this point in time, you're kind of used to me giving you some assignment, some homework problems where we never talked about it, right? Okay, that happens. That happens, right? Not a big deal because you do have a textbook, right? And a lot of times you read back and you do it, and sometimes it's on purpose and sometimes it's not. But anyway, not the end of the world. That's good for you. This isn't op calculus. It is AP calculus. All right. But anyway, most of the time I try not to do that to you. I really do. But here's the thing. Arcsecant. Here's where we have to think about this input-output thing again. What are the inputs to arcsecant? Values or angles? Values. The negative 1-to-1 thing. And these are angles here. Now, what do you know about secant as it relates to cosine? Reciprocal what? Angle or value? It's the value. So if you're doing like cosine of pi 6, that's root 3 over 2. The secant of pi 6 would be 2 over root 3. The values are the reciprocal. So in the inverse function, same thing. The value is the reciprocal. So this function is the same as arc cosine of. That's why there's no rule for arcsecant, arccosecant, and arccotangent. Because if you get one of those, and I'm not going to put one of those on the gateway test, but if you get one of those, you simply do the reciprocal of the inside, and it turns into the other thing. Okay? And I just kind of, I forgot to mention that. I thought yesterday, maybe in passing, I would just mention that, but because I know it was going to show up on the homework, but I kind of forgot about it. So, that would be the same as 2x to the negative 1, right? So let's do it. So the derivative is what? Negative 1 over square root 1 minus this squared, 2x to the negative 1 squared, times negative 2x to the negative second. So I think we could clean that up a little bit, put this on top, at least the negative times a negative I think we should do. So 2x to the negative 2 down here. This would be square root of 1 minus 4x to the negative 2. Remember, when you have a power on a power, you multiply the powers. So the 2 on the 2 times negative 1 there. Okay, I think that'd be good to do. This, you could drop that x down, but that's just rearranging, I think. But that little bit of simplifying, I think we could do. Okay, so there you go. So that's what would happen with 21. Okay, so this would definitely be something you could be asked to do on the gateway test for sure. Not the secant and flipping it part, but once I could give you that problem right there, arc cosine of 2 over x. I would consider that pretty easy, right? Because that's just the straight ahead rule. Just got to know the rule, right? Got to know the arc cosine rule. There's no quotient rule in there. No, So to me, that's an easy. Okay. All right. Let's talk about page 195. Anybody got something that they want to look at there? Anybody? Number 4. What's number 4 say?
T of u.
T of u. All right.
Equals u over the square root of 1 plus u squared.
Like that?
Yeah.
Okay. So I would probably you have an option here of making that a product rule by bringing the bottom up, or you could just do a quotient rule. I would probably lean towards a quotient rule. I know on the quotient rule, just because bringing it up gets a negative power, then you got to deal with that, which can be kind of messy. The quotient rule, one thing about the quotient rule is it'll be the bottom squared, and when I look at the bottom, it's a square root. That'll be nice, right, when I square that. So I like that. So from that standpoint, I think that's what I'll do. So quotient rule, so if you did a product rule, it's going to look different, right? And when you simplify as whatever you can, it'll still look different. That'll be fine. When I grade it, I'll follow your work and go that way. So if we're going to do a quotient rule, it would be like so. So derivative of the top is 1. Remember, it's with respect to u, right? We're doing the derivative with respect to u. So derivative of the top is 1. Bottom left alone, you could just put it as square root, or you could put it as 1/2 power. Either way is fine. Minus the bottom, the top left alone, and derivative of the bottom. Well, here I definitely want to do this, so probably should have done it with the other ones. We're going to do the derivative of the bottom, which would be 1/2 1 plus u squared to the negative 1/2 times the derivative of the inside to u, all over the bottom squared, which becomes just 1 plus u squared, right? Which is nice. Now, you notice that you have two things in quotient rule. You always have the u prime v part, and you have the uv prime part. And those two are separate things in terms. So now you deal with those, I think, individually. This one, there's really nothing I can do to that, so that's just going to stay. I'm going to write that 1 plus u squared to the 1/2 just to be consistent. Minus, now what can we do with this? 2 and 1/2 makes 1. U times u is u squared. 1 plus u squared to the negative 1/2. I cannot distribute that because of that power on that parentheses, so that's all good. And then 1 plus u squared. And I'd say that's all you got.
That's as far as
I think so. I mean, there'd be some things you could do as far as factoring out something here. The calculator probably didn't stop there, I'm guessing. Did you check that?
Yeah, like when I did it one year, I did like a cross multiply rule, whatever.
Or a split it apart kind of thing?
Yeah.
Yes. On this one, see, and this is where that line's kind of fuzzy as far as what you have to do and not have to do. Okay, and it just is. There's no, if there was an easy cut and dry thing, then I would tell you that. So what does that mean for you? If it's kind of a gray area on what you do, you I guess you do the best you can, right? You simplify as best you can. Do not try to oversimplify. In other words, don't go looking to simplify and do a bunch of that algebra on every problem. It's not going to happen. There might be 3 or 4 at the most. If you're trying to do it on every problem, do a bunch of simplifying, you're doing too much. Okay? And so to me, the obvious one is the u times the u, the 2 times 1/2. That you do. Now, you're right. Because I've got a 1 plus u squared here and over here, it makes me think, hey, there's something that could maybe cancel. We had that one yesterday we talked about where we had like a 3 tangent, minus 4 sine. I'm making this up at this point, but it's something like this, over tangent. And people are saying, hey, can you cancel those tangents? Well, I think what Matt is saying is that if you would split this, right, like so, then you'd have 4 sine x over tangent, right? This would be okay. And if you split it, you could cancel those, but not these over here. Well, we're not going to do that, right? And you don't have to do that. If you do, it's fine. If you do, it's fine. The problem is you try to do too much canceling and you do something that's illegal, then it ends up costing you. So right here, if I split this into 1 plus u squared to the 1/2 over 1 plus u squared, now you can think of that as to the first. Well, what do you do with those powers? You just subtract them, right? So that'd be 1/2 minus 1. That'd be 1 plus u squared to the negative 1/2 right there. And then minus. And then if we split this, we put this over this. Well, again, if we think of that as a 1, well, right there we can subtract those powers. Negative 1/2 minus 1 is negative 3/2. So this would be u squared and 1 plus u squared to the negative 3/2. So that whole thing could be simplified down to there. And then again, the calculator may even do some more, but a lot of this is just rearranging at this point. So I'm perfectly fine with you stopping to there. I think that's fairly obvious. Simplifying the rest of that, not so much. Okay? All right. And this is why all this extra practice is important, because I'm going to answer whatever questions you have, but if you haven't practiced a lot, you're not going to run into these, right? Because the more you practice, the more you run into all these different situations, and the more comfortable you feel handling. You get to the gateway test, you haven't done that much practice. You think you've done some, but it's not really enough. You get to the gateway test, you're in these situations. I never saw that. Well, you would have probably if you'd have done a few more. All right, so that's the key. The more you do, the more you feel comfortable with the different things that pop up. Okay, another one.
16.
16, read it.
G of t equals the square root of quantity 1 plus t cubed cosine t.
So 1 plus t cubed in parentheses?
No, just t times cosine t.
Gotcha.
So
Okay, so 1 plus
t cubed cosine t.
like so.
Yeah.
Okay? All right. So this is all to the 1/2 power, right? So g prime. So outside, bring that down, right? 1/2. Leave the inside alone. To the negative 1/2, right?
Yep.
Times the derivative of the inside. Well, that's a big mess. Not a real big mess, but it looks like a product rule sitting there, right? The derivative of 1 is just going to disappear, so that's not going to matter. But I'm going to need a big set of parentheses to hold my product rule, right? To hold my product rule. All right, so derivative of 1 is 0, of course, so that goes away. So it's really just this I'm looking at, so I'm doing a product rule. So derivative of the first, 3t squared, cosine left alone, plus, I'm not going to write it now because I think I know what's going to happen. I'm going to minus there, aren't I? Because I leave the first one alone, which is t cubed, and then I do the derivative of cosine, which is negative sine. Okay, now a comment about that negative, because again, I see this all the time. I see somebody go 3t squared, cosine t, sorry to those people watching the video, and then they go plus t cubed, and then they go, oh, and cosine is what? Negative sine, right? And they write it like that. That's wrong, because that's a subtraction sign written that way. It's not. It's times negative sine, right? So stick that negative around in front, and you won't confuse that. All right, so anyway, we get that, and you're done. Right? Again, this would be one where you would overthink it about trying to simplify something. I mean, you could take out of this, you could take out a t squared, I suppose, and bring it over here, but I don't know why, because it wouldn't cancel with anything. I just wouldn't do anything else to that. You're done. Okay? You're done. Okay? Make sense? Okay? What else? One more. We're going to shift gears here a little bit and show you the websites. Number 7. Read it to me.
W equals e to the u squared.
The whole thing squared or just the u? Just the u. Okay? So it's more like this, really. Okay?
Times tangent cube root.
Which would be u to the 1/3, right? Like so. All right, so how do we start this one? I mean, like on this last one, I started this as a power rule, right? The outer function was power. What's the outer function here? I mean, what's you start with a product rule, don't you? What you have here is a u times a v, right? So we're going to start with our product rule. So we're going to do the derivative of the first. So we got u prime v plus uv prime. So we're going to start with the derivative of the first. So let's just look at that. So what's that derivative? E to the u squared. E is its own derivative times derivative of the inside, 2u, right? 2u. So all that is the u prime times v, which is the tangent u to the 1/3 left alone, plus the first left alone, which is e to the u squared, times the derivative of this. So now I'm focused on this blue part. So the outer function is, well, yeah, the outer function is tangent, so the derivative of tangent is secant squared. Okay, so secant squared of the inside left alone, u to the 1/3, times the derivative of its inside, which would be 1/3 u to the negative 2/3. Barely in. Okay, I think I'd learn to start over. Okay, so we got that. So then we step back a little bit and we look at it and we think, okay, is there anything there? And neatness counts a little bit here, doesn't it? I mean, how you write it and how, so then you can look at it to see, you know, if you need scratch paper, want to do this work on scratch paper so you could write nice and big, because some of you have seen your handwriting, you know, you're on your homework when I come around. So, you know, because then you can lose things. You lose negative signs, you lose, I mean, it's really difficult. So I always try to write really big that way. Because what I'm looking at is one thing here and one thing here. That's what I've got. There's two terms. So I'm looking at this. Anything I can do there? And just be rearranging. Well, I mean, I could bring this 2u around. I could do that. I was telling the other class, I should tell you guys this. When we have that, it's just a pet peeve of mine. This is where rearranging might be a good thing. When you do the derivative of this with that implicit, right? Product rule, the derivative of x squared is 2x. You leave the y cubed alone. Plus x squared left alone. Squared y prime. But that always drives me nuts when people put that 3 in there. It doesn't look strange. I mean, it should be out front, right? And so when you have that, especially if there's another number out here, then you would definitely need to put it together. But don't leave it. If that's the final answer, I mean, I probably won't count it wrong. I mean, if that final, well, it's not going to be the final answer because you're going to have to get y primes on one side, right? But I see people write this the first time, that's fine, but then they start rearranging and getting the y primes on one side and factoring out, and they keep leaving that 3 in between there. And it just, I don't know, it's like fingernails on a chalkboard or something to me. But anyway, that's just a pet peeve. So I digress. Anyway, right here, if you're just going to leave that, then I think that's fine. You know, that 2 seems a little weird right in the middle, but that's okay. And here, anything? I mean, I can bring the 1/3 around in front or something, but really it's just rearranging, right? There isn't anything I can put together. So I think you're done, right? Just product rule and you're done. Okay? So like I said, you don't go, I mean, you look, you take a look, is there anything I can put together, anything I can factor out, maybe cancel or whatever, but a lot of the times there isn't. A lot of the times there isn't. So if you're trying to do it on everyone, you're probably doing it too much. All right. Let's talk about basketball. No. It's not here. Okay. More basketball. All right. Here we go. So on our website, there's a couple different places here. On Fridays, under Friday's link, today's link, or if you go under web links. If you go under web links, there is Derivative Practice 1 and Derivative Practice 2. Or if you just go under today's Friday assignment, I've got links there as well. Okay? So if we go to Derivative Practice 1, it looks like this. This is from Bluffton University. Okay? So you've got functions here. You can set your difficulty level at 1, 2, 3, 4, or quite nasty.
Quite nasty.
There's a quite nasty.
We're not gonna have any nasty.
I mean, I would not do those. I probably wouldn't go beyond about level 3. I don't think on these. because all they do is they just put layers inside of layers inside of layers, and it's just probably not going to happen. Level 1,
Oh, wow.
okay,
I'll do
cosine e to the x, square root of x. Now, the other thing that's nice about this is you can pick certain functions. Like, for example, I just have e, sine, cosine, and ln, just your very basic ones, okay? But it allows you to say, okay, I haven't practiced any of these, 2 to the x ones for a while, and now it's also going to give you your basic polynomials, your power functions, your square roots in there too. Those are always going to be in there. But then these are additional ones. So if I do this, I get a bunch of power functions. I'm still on level 1. Let's go to level 2. And even level 2 is not real difficult. There's a 5 to the x they throw in there. Now remember, derivative of 5 to the x is
5 to the x.
5 to the x.
Times 1 over ln.
Not 1 over, natural log of 5. You do 1 over when it's a log, right? So let's look at one of those. So let's do a log. So right here, log base 6 would be 1 over x times 1 over ln 6, right? 1 over x, or 1 over whatever the inside is, and then 1 over ln 6, and then times whatever the derivative of the inside is, right? The u prime part. So it allows you to just practice. Don't worry about this bottom row at all, but it also allows you to do some inverse sine and cosine as well. Secant, cosecant, cotangent could be on there. We haven't done a lot of that. Derivative of secant is secant tangent. Derivative of cotangent is negative cosecant squared. That's on your rule sheet, so you got to do those. But inverse, that's what they do for arc sine, right there. A sine x. That means arc sine of x. Okay? So these 2 rows, and then of course it'll give you those. 2 is not a bad level to do, but they'll give you some product rule, probably give you a little bit of quotient rule. I'm not seeing a lot of quotient rule right now in here. There's one. So finally, there's a quotient rule 1. 3's not bad. That's probably about as high as I would go on these, probably. If you get to 4, that's like 4 things multiplied together. Now, you could put 2 of them together. Actually, 3 of those you could put together by adding their powers. And I'm not going to make you do a lot of that kind of simplifying. Here's a product rule in the middle. So 4 you could do. There's probably better practice. I think page 195 is good practice, and it's got like 60 problems or 59 problems. So that's a lot. I think page 195 I still think is really good practice. Okay, and I'm going to show you another website. But this can be good because it'll show you the answer. When you type something in, if I submit my answer, it'll say, hey, you're incorrect. And I thought somewhere it would tell you the answer. Maybe, no.
The answer. It's under answer.
Thought it did. Well, that's definitely not the answer. So, yeah, that's my answer. But, I don't know. I thought it did. But anyway, maybe it's because I didn't even come close. So it's I'm not worthy of doing the answer. So, so x cubed, so 3x okay, and it says correct, but I don't, that's weird, let me do it. It just says incorrect. That's interesting. I could have sworn. Must be missed something.
Click on the 2 down below.
Yeah, that just tells you how to enter them, and then this just gives you some other things. But so yeah, I'm not sure. All right. So anyway, back to this. So that's not a bad website. website here. And then this is from Arizona State. It's quite old, but it's still up here. So practice test 1, practice test 2, practice test 3, and it's got solutions. So what this does is just brings up a PDF, okay? And this isn't bad. It starts off kind of easy. So you've got just kind of some basic ones, and then you get into, then it goes to some quotient rule. Now this one I would probably simplify first. You know, you could split this apart. But then on this one, you couldn't split it apart. I think that's why they picked those two. They did them like that. So this one, I can go x squared over x squared. I don't plan on giving you any that where you could simplify them first. They're pretty much just going to have to do them with the rules. So there, then you get, see again, I would distribute this rather than do a product rule on it. Another quotient rule. So the first page is pretty basic with those kinds of things. And then, I don't know why that would be a bonus. We should be able to do that one. So that's test 1. And then test 2 gets into some more chain rule now. You start getting into some chain rule. There's some product rule. It does have a nice mixture. You got a 2 to the power, which you got to remember that. So there's a fair amount of chain rule then with some quotient rule mixed in as well. But there's an arc sine, there's an arc tangent, there's an arc cosine, and then you got some more down here, which we'd be able to do all of these here. So those are all good ones to get into. There was a cosecant I saw. Yeah, right there, there's a cosecant. So there's a lot of them on that. That's a really good page, number 2 there, because that's really a lot like what ours will look like with those problems. Also, practice 3 here I think is a good one. You got some product rule, you got some arc sine. There's a 10 raised to some x's, so we want to be able to do that. There's a 5 raised to the x. Now this number 3 is where you get into a little bit of the implicit. So there's your mixture of x's and y's. So you're going to get a little of that. Here's another mix of x's and y's. So we haven't had a lot of those other than that one page in the book where we did the x. Here's another mix of x's and y's. Here's another mixture of x's and y's. So you got several here at the end. That looks very much like one we did in the book, so that might get a little harder and we'd have to do. Same with this one probably, but one like 18 is definitely one like we've been doing. Okay, so derivative practice 3. So those 3 are all pretty good, good ones here. And then this must have been their actual test or something. I'm not sure. And it's got them, and then it's got answers right there with them. But okay, so I've got those 2. So you got page 195. And you've got that website as well. So I think probably right now, I think people are at different spots. I'm going to let you work. And then we'll use Monday too, because I don't have much to add. You can sit and watch me do them all day, but I'm not taking the test. So, okay. So page 195, if you want to, get the little groups and work, you can. If you want to pull up your Chromebook and get on one of those websites and practice some of those. Like I said, 195's got a lot of good practice. I mean, you can practice that page. The only thing 195 doesn't have, does 195 have many arc sine or arc cosines? Did you see many there? Okay, and it doesn't have any implicit differentiation. So the only place to get the implicits, a little extra implicit practice is here. And I wouldn't do all those. I would do a few of those and then maybe come back over the weekend, do a few, maybe on Monday do a few, just so you stay fresh with everything. Pick some, look at your derivative rule sheet. Try to pick some out that have some of all those different rules so you're getting a sense of all the different rules too, like secant and cosecant. Okay? Implicit, there would be 2 at the most. 2 at the most implicit, right? The rest would be the rules on that rule sheet. Okay? All right. Rest of the time is yours to work. And again, if you got some questions, I'll just be up here and I'll answer questions for you. Okay? All right.